Hi, I'm Andrew, and I also got my boy Kusek here. So today we're going to talk about our research on 5G technology. So we're going to go ahead and get started here. All right, now we can start things off with a joke. So here is a relevant meme around 5G. Corporate needs you to find the difference between this picture and this picture. 2020 says they're the same picture. This is more or less just a joke on how due to the upcoming of 5G, there are some conspiracies around 5G, and as a result, a lot of 4G towers were mistaken as 5G towers and either shot at times with technicians working on it, people taking pictures of it, thinking that, like there's some weird conspiracy going on, or people straight up burning down a 4G tower. There's a lot of controversy around 5G, so this is just making light of that situation. Hope you enjoyed it. Alright, to start off, what is 5G? Qualcomm describes 5G as the fifth generation mobile network and wireless standard designed to interconnect people and devices. 5G is based on the orthogonal frequency division multiplexing, or the OFDM modulation method, so it can modulate digital signals across several different channels. 5G is designed to provide a much faster and reliable mobile broadband service than 4G while interconnecting Internet of Things devices. So why does 5G matter? Based on the U.S. Census regarding Internet access, most Americans have cellular data plans for Internet use. As a result, 5G's implementation improves most Americans' access to the Internet, whom of which rely on mobile devices to access the Internet. As of 2016, 83.3% of American households have cellular data plans, and following the graphical trends of mobile device adoption, it's very likely to be much higher now in 2020. So who invented 5G anyway? 5G is being developed by the Third Generation Partnership Project, or the 3GPP, with a total of 7 organizational partners. As you can see on the right there are 7 of them. Each of these members represent some kind of region or country and encompass many different tech companies. In the United States in particular, the one on the top there, ATIS, or Alliance for Telecommunications Industry Solutions, represent US-based companies and have many companies such as Apple, Cisco, Qualcomm, and so on. So how does G3PP operate? Each partner works together to establish standards for mobile devices and communications for universal use, and their operations are in 3 different categories, as you can see on the right. So that is radio access networks, services and system aspects, and core network and terminals. And if you want to hear or see more information, it is available on the G3PP website listed in the slide. Alright, so now we'll talk about 5G specifications. So, since 5G is developing, the exact technical capabilities are subject to change. However, 8 specific requirements exist that are defined by G3PP. So there's 8 specifications that must be met, and they are listed in the chart on the right there, or the graphic I should say. Highlights of what 5G will be capable of include up to 10 gigabits per second data rate, high availability, so near 100%, 1 millisecond latency, up to 10-year battery life for low power Internet of Things devices, as well as operating in multiple bands such as lower power bands below 6 gigahertz and wave or higher bands above 24 gigahertz to provide wider bandwidths. This basically gives it the flexibility to choose between low range and high speed versus high range and lower speeds, which should allow it to be implemented in many different places for different requirements. So now we'll talk about the FCC's involvement with 5G. The FCC regulates all types of communication to include cellular communication, and it has allotted the required high band, mid band, and low band spectrums required for 5G to operate, as well as giving it access to some unlicensed spaces. Furthermore, the FCC has been adjusting regulations as a response to 5G's upcoming. And if you want to learn more about it, you can visit the FCC sites listed in the slide here.
All right, thanks a lot, Andrew. Hi guys, my name is Michael, and I'll be building on what Andrew said about 5G. First things first is one of the huge differences with 5G is the wavelength and the frequency that it transmits. These frequencies are much higher than previous generations. The frequency does allow for a higher bandwidth, however, at the cost of range. That's why they have built small cell towers. These act kind of as just like a middleman between the large cell towers and the device, i.e. your cell phone or what have you. 5G will not support legacy hardware. However, your 5G device can be backwards compatible and connect with 4G LTE towers. So here we have the wave spectrums. These right here are sub 1 gigahertz. They're called sub 6. You could typically see 4G operate here, right in here between the 3 and 5 gigahertz. This is also where 4G operates. Pretty common. Nothing exactly new there. However, this is where 5G separates from traditional standards. You're seeing much higher waves between 24 and 30, and they're even testing some as high as 70 gigahertz. So MIMO and beamforming. One of the key technologies is the use of 4x4 MIMO. MIMO stands for multiple input, multiple output. MIMO is the implementation of multiple antennas built into the device and base station. So, the simplest way of looking at it is more antennas, more data is being transmitted. Base stations will also use what's called beamforming, and this is actually able to direct these beams in a coordinated pattern, coordinated direction, as to get a more efficient and faster connection. So 5G and SDN. SDN stands for Software Defined Network. It is a major feature of 5G. We did learn about this a little bit. It was originally created for databases. It removes the control panel from the centralized hardware and allows for the control of data through software. This allows for easy changes and upgrades and scalability, which is one of the major features of 5G. And it allows for more machine-to-machine communications, and in general, it's just more power efficient and cost effective. So 5G and the Internet of Things. 5G is welcoming in the new age of wireless communications. We're now able to connect more and more devices than ever before with reliable connection and speedy delivery, along with low latency. This will allow us to connect things to the internet that we've just never seen before or even imagined. For example, a pipeline will have a sensor in it that will detect if it's too high of a pressure, too low, and then it will talk to another computer and it'll be able to adjust accordingly. So 5G does raise some safety concerns. There are a lot of critics of installing these towers on every street corner all over the place. These waves are, well, they are radio waves, they are microwaves, and they are radioactive, so people are being scared thinking it's cancer causing, and we shouldn't be inviting such a thing into our communities. Ultimately, it comes down to what is an acceptable amount of radiation. Sunlight has radiation. You know, the old radios, those are radioactive waves. So, you know, there's not enough data really to say whether it's safe or unsafe. We just don't know. It could be the amount of waves that we would be subjected to could be harmful, or you know, it might not be. We simply just don't know. And then here are some of my citations for my project. You can pause the screen now to go into depth on those.